So, welcome to the next talk. My name is Sascha Schwarze. As announced, I am an IBMer. So we are the IBM team, as I learned. Guess what? There are more, but they are not here. I'm from the IBM Cloud Code Engine team and active in many open source spaces. So I'm co-leading the Shipwright community. You'll also find me committing in projects like Tekton or Knative, and sometimes in Paketo. And with me
is Matthias. I hope you can hear me. I'm also with Sascha at Code Engine, and I'm a maintainer in the Shipwright community, hence the T-shirt.
Thanks. And we are going to talk about our experiences in adopting Paketo Buildpacks in Shipwright and in IBM Cloud Code Engine. So 3 terms now thrown out. Let's quickly go through them to give you a brief introduction what they are. So what are Paketo Buildpacks? So Cloud Native Buildpacks, probably for the Cloud Foundry community, the most known. So they analyze source code, download, build, and runtime dependencies. They build your source code, and Cloud Native Buildpacks then export the runnable application as a container image. So Cloud Native Buildpacks kind of provide the specification, and Paketo Buildpacks provide the implementation of Buildpacks for certain programming languages such as Node, Python, Java, and so on. How are you using these Buildpacks? If you want to do it locally, you need a CLI tool called Pack. And guess if you have source code on your machine, just navigate into this directory and call pack build, the name of the container image that you want to build, and you need to point to a builder. The builder itself is also a container image. It is kind of a collection of 2 things. It contains the lifecycle binaries. I'm going to talk about what they are in a moment. And they contain all the build packs that the person or organization who has put together that builder image decided to include. The builder image that I'm using here in that command is the full builder from Paketo, which kind of excludes everything that they have. So when you run this command, Pack will download this builder image and run Docker containers sequentially to run the different lifecycle phases. What are those lifecycle phases? So the lifecycle starts with analyze, where it looks at your container image, if it exists already, to check, okay, what has been built there maybe 1 week ago, to see if potentially later something can be reused. Second phase will be the detect phase, where Buildpacks check your source code, like the Maven Buildpack will look for a POM XML, and guess what? If there's no one, it says, I'm not participating. If you have a Node application and there's a package JSON, then the npm install Buildpack will say, hey, I'm participating. Following the detection phase is the restore phase. That's there when things from your previous image get restored. Staying with the Node application, if you have a package JSON that was unchanged, so you only changed some of your application source code, then it doesn't need to rerun npm install and download all the dependencies. Instead, it can restore this from your previous image. Nice and efficiently. After restore, there's the build phase, where depending now on your programming language, it will run the commands that are necessary to build the application. Last phase is then export, where the container image is produced. That's how Paketo Buildpacks work.
So now, for the sake of completeness, what are the other terms that we mentioned so far? So what is Code Engine? I make my life easy and just refer to the product documentation. So it's a fully managed serverless platform that runs containerized workloads. The emphasis, and this is why we're here, is containerized workloads. And furthermore, it also has the capability to build source code into containerized workloads. So with that being said, what is now Shipwright? Shipwright is, so like Cloud Foundry, we have built capabilities to have source code to, in this case, container images. It doesn't really care or matter where the source code is, so we support remote Git repositories as well as local source code on your disk. And to borrow from our old favorite haiku, here's my code, run it on the cloud for me, I do not care how. Like, if you do care how it's done, this would be Shipwright for us. So Shipwright is a open source, vendor neutral community where we basically baked build capabilities for source code and these builds run natively on Kubernetes. And this is actually what we use under the cover, for instance, in Code Engine. Now, in order to make sense of some of the things we say and then get the arc back to Buildpacks, we have to talk about some building blocks so that it makes sense. So first of all, there's the build strategy. The build strategy is, so to speak, steps that you would need to get from source code to your container image. And how this is done. Then there's the build. The build kind of contains the hard facts, like where's the source code, how do you want to perform the compilation or whatever, like what is the strategy you want to use, and where do you want your container image to land in what registry. That contains the hard facts about the build. And the build run is just the execution of a build. So again, from looking at it from Cloud Foundry perspective, I think build and build run is more a singular concept in Cloud Foundry. Here, for some reasons, this is separate into two, which kind of opens some interesting use cases. Right, which kind of brings us back to where we started.
Yeah, how does Paketo now work in Shipwright? So Matthias spoiled that we have build strategies that define how you turn source code into a container image. And guess what? One of the build strategies that we have in Shipwright is in our Shipwright samples is the one for Paketo. So just quickly, there are other sample build strategies, also for Dockerfile-based strategies like BuildKit or Canico, for other Dockerfile-less strategies like KO, just for completeness. But this is how a Kubernetes manifest would look like for a cluster build strategy, some metadata, parameters, volumes. We are not looking too deep into that. And then there are the build steps that Matthias mentioned. One thing that is worth noticing here is in this build strategy, there's nothing that takes care of getting the source. So this is what Shipwright provides, and you as a build strategy author can fully focus on the steps to get to a container image. So there's no git clone in here or anything similar. It assumes that the source code is there and it actually can access it at this predefined system parameter here. Then there's a script that's kind of common in many of our build strategies, that we then have a script which does the things. There's some preparation stuff here, and then there's one thing that you will not find, and that is pack. So we won't run pack in here because, I mean, this runs at the end in a pod in Kubernetes. Running pack would mean we need Docker, and running Docker in Kubernetes security-wise is a pain. So we instead enter one layer deeper and directly invoke the different lifecycle phases one after each other in the same order I had explained them. And that's basically how Paketo can work in Shipwright. Back to the slide. So yeah, I mentioned the pack point already. Now, pack isn't a dump tool. It doesn't just invoke the lifecycle binaries. It has some capabilities on top, meaning that if you don't have pack, it really depends on how advanced you implement the build strategy to have these capabilities available as well. To give you two examples, in pack you can provide environment variables to give guidance to the build packs on how they should build your sources. Like staying with the Node.js example, there's an environment variable BP node version where you can say, hey, I want this to be built with node 16 and not with the default one, which these days is node 18. And so we have things in our build strategy that support environment variables, so you can provide them there, and that capability is available. What we don't have available in our build strategy, on the other hand, is bindings. Bindings are things where you mount a whole file to your build at runtime, at build time. Example would be that you mount an npm RC file so that in your node world, again, you can pull from a private npm registry. That's something we don't support. Technically, with some maybe with some necessary enhancement in Shipwright, it would be possible, but it depends on how much you want to spend effort there. Spoken too much in text. Let's see how it actually works. So this is the IBM Cloud Code Engine CLI. think of this as a CF push. So app create, name CF day, source is dot. So in the local directory where I have a tiny Go application, we decided against polluting this command with the whole build run logs. But now we're interested in that. So I've copied the build run name and in a separate tab following the logs. Now here we can see that it is starting the Buildpacks phases, analyze, detect. Now it's already in build, running a Go build. In a moment it is going to enter the export phase where it is going to store the resulting container image in a container registry, and it is going to save some cache artifacts so that a later build run could actually reuse them. And okay, build run completed successfully. I'm jumping back to the other tab. The command already noticed here that the build run was complete. It's now bringing up the application and is going to make the route to the application ready so that we at the end have a URL that we can open, and that works. So under the cover, what now happened is the CLI had created an application in Code Engine that's backed by Knative, nothing we speak about today. And it had created a build run, which is backed by Shipwright, and it uses a build strategy, which is using Paketo. That brought everything together. Nevertheless, so you've seen it working, but this wasn't without challenges, or still isn't without challenges. So let's go through a couple of them.
So I mean, Buildpacks are great. So as someone that did operations on Cloud Foundry and you get support tickets from users, I think most can agree that Buildpacks are great, but they also have their challenges. And you might have read from the abstract that we kind of started adopting Paketo Buildpacks very early. And starting very early has pros and cons. And one of the things we figured out, there are some features that were just missing. But on the other side, this gives us the great opportunity to actually contribute back. So for instance, things like multiple jar file support in the Java Buildpacks, or out-of-the-box build script support in the Node Buildpack. So we were able to contribute things back to the community in order to fill the gap what we need. And this is why I do love Buildpacks. It's great. However, what sometimes can also happen with Buildpacks is you get behavioral changes, right? So the community does something that makes sense, but you actually end up, from an end user perspective, with a build that doesn't work anymore. And yeah, that's a pain. You have to somehow tackle. And you might have guessed, like, the usual suspect to find a solution for that is regression tests. So basically what we also started to do is iteratively, step by step, improving our end-to-end tests to include things where we know user expectations versus what's currently happening, to just catch those behavioral changes as early as possible to, either find a workaround, mitigate it, or contribute something back to the community to address the issue, really depending on the use case.
Yeah, the next challenge was already briefly touched, and that's having pack versus not having pack. So beside that, we kind of need to re-implement some of the capabilities that are in pack in the build strategy. There are more challenges. Like, we cannot easily tell a Shipwright user or a Code Engine customer to go to the Paketo documentation to learn about how those build packs work. Why? Because, or the Paketo samples actually are another example. Why? Because when they go through this, they will always read, then you need to do this, pack something, and then the sample commands simply don't match what we have on our side. So we kind of need to duplicate certain documentation things. We're not so good there actually. But yeah, this will come and get better. But it's work for us, obviously. Something that we are actually hoping for, and that's something that the Buildpack community had. I mean, there's only a pull request for RFC, so it's not even a merged RFC, and that's the so-called prepare phase. So that would be something at the very beginning, even before analyze, where some of the capabilities that today Pack has would be moved into that prepare phase, so that when you enter that layer deeper, direct on the lifecycle phases, you could leverage that. But yeah, that's future maybe.
Yeah. Speaking of other future stuff, exporting to file system. So we had this great talk about supply chain security today, and actually we did a separate talk on CDCon Vancouver this year about Shipwright in the supply chains, or if you're interested in that, check out, so shameless plug here. But this feature is actually something we needed to enable features for supply chain security improvements. And this is when you build, what Buildpacks are doing is they build the source code into a container image and they push it to the target registry. That kind of sounds nice, but is sometimes a problem because it robs you of some of the very nice use cases. So what would be nicer if you don't push the registry immediately, but you export what you just produced to a local OCI directory in the build pod, and then you can run tools on it. So for instance, we have some use cases in Shipwright where you can run, for instance, vulnerability scanning on that directory, because if you find a vulnerability, it makes no sense to push the image to the registry if you know there's something in there you don't really want to push. Others are like SBOM generation for checking licenses, checking things that are in there. So there would be some very nice use cases to actually don't push directly. And like I said, in Shipwright, we have a feature where we basically have a hook that where we can do things prior to a push. But this only works for strategies that allow us to configure that moment. For instance, BuildKit, like what most people know from Docker builds, right? This allows for basically to not push, but have the export, and then we can do magic on it. Buildpacks has an RRC, I think a merged one, but there's no workable solution at the moment, but maybe in the future for more security.
Yeah. The next challenge is user expectation. And that's something that we've observed as an operator for Cloud Foundry over years, and these days also with Code Engine. Basically, it's about that promise that tells you, give us your source code, and magically we make a runnable application out of it, in brackets, that behaves like you expected. And that isn't always the case. So you can do many things right and wrong as a user. Basically, in many places, Buildpacks rely on a certain directory structure, which kind of is the default one on how you do an application, on how you build an application. That's mostly given. So like you find your package JSON at a certain location, and or your POM XML for Java or Go mod for Go. These kind of things are easy, but then there are often customizations that you need to do on top. Like on a Go application, you suddenly have to specify which package is your main package so that this one gets built, especially if there's more than one. And so that's something where you need to kind of tell the users then, okay, yeah, magic is there, but you need to help the magic to work, to behave correctly. Another example is, and that would be something where the build could fail, even critical is when the build succeeds, the application doesn't start, okay, that's also okay, but if the application then does start but doesn't behave correctly, I mean, that's the worst thing. The example that I like to mention is one that actually exists in the Paketo samples. Should maybe not say that too loud here, but there's an example for an Angular application. And I mean, who knows Angular or React, Vue a little bit? Okay, well, not too much. But anyway, so there's a package JSON node, and that defines a build script, which transpiles your Angular code, React code, whatever, into static files. Perfect. Paketo will run that build during the build phase. Perfect. Mission 1 accomplished. But now, at runtime, what you want to do is you want to serve these static files through a web server. But if you don't do anything, Paketo is going to look at your package JSON and finds a start script. And the start script suddenly does a development build of your source code again, and brings up a dev server which isn't at all optimized, meaning you can build that application, it will build things at build time, you can run it, it will start up, it will be functional, but it will start slowly because it compiles everything again, and it isn't optimized at all. So these are then these kind of examples where hand-holding is needed to build the optimal application with Buildpacks.
And lastly, let's talk about support statements. So providing an enterprise level product with build capabilities means for clients that they want the thing to be reliable, but also predictable. And that's sometimes not that easy because clients use a lot of programming languages, certain versions of a programming language, and they kind of, like from support tickets we can see, they want to know what version they can expect to run for how long and what's going to be next. And we have to come up with those statements. Problem is we are not directly, it's outside, a little bit outside of the sphere of our influence because it's written in the build packs, obviously. So we have some nice automation too. With every change of the build packs, we automatically update our product sites with the current version so that we can always point there and there, this is the truth, like these versions are for you, but we would like to have more. And this is also a challenge we still have. Things like end-of-life dates for certain versions of programming languages. So the build packs spec actually introduced a deprecation date. That's great. So for some build packs, you will find for certain versions, this is deprecated at that point in time. However, this is not universally available for all the build packs, so we can't, or not yet, rely on those spec things. So this is what, it's a challenge, but also like a hope for the future, because specs can change, and this is like a good thing that happened. And if this is basically adopted better over time, then we can basically give better, predictable support statements to our clients when using build packs.
So there are actually more challenges one could talk about, but time is over. So with that, we'd like to say thank you, not just to you, all of you who listened now, but also a big thank to the Paketo community. They provide really a great thing. And also when we work with them, just yesterday I received an update in a really complicated, from my perspective, issue that we have in the Python build packs. So I wasn't able to figure it out. It took them some time to look into it, but now finally somebody's looking. Also when we contributed, we always got help with feedback on how we did things or how we should do things. So that's always great. We've put 3 QR codes on the screen. If you want to learn more about Shipwright, Paketo, Code Engine, go there. Beside that, we are done. Any questions?
Thanks for the talk. Questions? Yes.
Actually, I'm not, I did not quite understand where you are heading. Wasn't this just a proof of concept with these 3 products here? Get them work together? Are you looking into offering Shipwright as a service at some point as part of the IBM cloud, or is Shipwright the missing piece that was left once you shut down Cloud Foundry on IBM cloud?
No, this is reality. So IBM Cloud Code Engine exists for the image building part.
I know.
For the image building part, it is using Shipwright. And our customers, we are offering 2 so-called build strategies. One is based on Paketo, the other one is based on BuildKit. So what we've talked about here is all reality.
Okay. And the Shipwright itself and the build strategies are part of the cloud offering, of the platform offering.
Correct. So we operate this as part of the offering, just like we operate other open source things that I mentioned, like Knative, Istio, Tecton, and so on. Yeah.
Thanks.
But it's an, like, seriously, it's an open, vendor-neutral community. Mm-hmm. We have community meetings every Monday. Everybody is welcome to join. Like, if you love like the CF push experience with building source code, and you maybe need that in another use case with Kubernetes, Shipwright is basically your best analog thing you can have to basically have the same build capabilities you know and love from Cloud Foundry, but you have that on natively on Kubernetes.
Okay, thanks.
Shipwright, right.
Thanks. So I was just from listening at the first part of your presentation, it felt very similar to KPAC. So, and then you continued and you talked like about BuildKit, and then I opened your documentation, saw like Kaneko and other things. So do I get the right idea that this is like a more flexible or platform agnostic version of the same thing? Just if you like reach a limit where you can't solve it with build packs, then you can do something more flexible like a Dockerfile build.
You got it. So Shipwright kind of is a tool agnostic thing. So it doesn't by default, it doesn't know anything about which build tool you're using to make a container image out of your source code. Paketo is just one option. The Dockerfile tools, BuildKit, Canico, Builder are other options, and anything else that exists on the planet. Kpack indeed is a cool tool, but it has that pure focus on Buildpacks.
Yeah, it's limited
so
to that.
we cannot, I mean, we could have used this also for Code Engine, but then we would have needed something else to provide Dockerfile-based builds. So that's why we like Shipwright.
Okay, thank you.
Any more questions? All right then. So we now head into a short break.